All right, we're back with part 2 of this problem. Sorry, the last one cut out kind of weird. I had a problem interpreting my notes, but I figured it out. Because this should not be Q. I'm just going to rewrite the answer on the other side of the sheet. This should not be Q. Q doesn't even exist in this one. This should be your sigma. So our answer to A that we're going to have is cap D over D is a function of rho GD squared over sigma and Q square root G D to the 5 halves. Moral of the story is have notes cleaner than the ones I had. So yeah, that's your answer to part A. I was going to break this up into 2 videos anyway, so it works out, I guess. So part B that we have is we're looking at the relationship between a model and a prototype, knowing that they're going to share the same fluid, but they're going to have different diameters, or this flow rate and this diameter here. We'll see how that works out. So let's see. So using similarity of this first, our second, or third pi term, whatever this pi term is for us, we'll use similarity of that first. Knowing that we have the same surface tension because we have the same liquid and also the same density. All right, so so the diameter in our model is G over GM times the diameter in our prototype. The relationship between these is that the G in our prototype is 10 times GM. And the diameter that we're given for our prototype is 0.25. So the diameter in our model is going to be this. Now we can solve for our the flow rate that we're looking for. So using this relationship here, so QM over, not rho M, square root GM dm to the 5 over 2. We'll use that similarity. And so we know, so solving this for the flow rate in our prototype, that's the relationship between our, or let me write this out real quick. So QM GM over G dm over D to the 5 halves. And then we'll plug numbers in to make things a little bit clearer. So Q is equal to 1 over 10. Same relationship as up here, except flipped, right? Multiplied by the diameter that we solve for up here, right? The 0.791 over 0.25 to the 5 halves. Or this needs to be multiplied by Q. And then multiplied by the Q from our prototype, which is given as 0.001. So our model flow rate is 5.63 times 10 to the negative third feet cubed per second. And that's your answer there. So, all right. Thanks for sticking with me over between the 2 videos. Sorry, my notes were a little less clear there. But these will be your 2 answers for this. So this would be your answer for B, would be this flow rate that you found. Your answer for A would be this set of dimensionless variables. Another way you could write the solution out is, say, pi 1, pi 2, or that was pi 3, pi 2. And you could just write them out and then box them. But this is kind of the better practice way of doing it. So, all right. This problem 3, this one's going to be kind of wild. So I think this is going to be trickier than anything you're going to see on the exam. So make sure you watch this one as well.